Hello. So today we're going to talk about chapter 2, or at least the beginning of 2. Starting with rate of change. Average rate of change of y with respect to x is just your change in y over your change in x. It's called your slope. And they also look at it as rise over run. But it's the slope. If we look at a problem, the consumption of margarine in pounds per person decreases from 10.9 in 1990 to 4.6 in 2006. Find the annual average rate of change. Now, when you're finding your rate and change, we want the change in y over the change in x. Pounds is on top because per means to divide, so it's pounds over person. And we want 4.6 on the average rate of change. Oh, annual. So so if we look at our pounds, 4.6 minus 10.9 in years, because annual, 2006 minus 1990. Now, if you're going to enter that all at once, you need to put parentheses around it. And when we divide them, we get 0.39. We'll go 2 decimal places. So the consumption of margarine in pounds per person is decreasing by 4/10 or 39 hundredths. Let's try another one. Suppose Joe's weight 5 years ago was 135 pounds and his weight today is 143 pounds. Find the average change in weight with respect to time. So we'd subtract our weight, because weight with respect to time means the weight's on top. 143 minus 135 over 5 years ago. So our difference in time would be 5. So we have 8 divided by 5 is 1.6. So the average change in weight is 1.6 pounds per year. So he gains 1.6 pounds per year. You can also find the average rate of change from a chart. Same steps though. If we want to find it for a verbal, we use the verbal. And notice you're just taking and subtracting these two and then these two. So for verbal, it would be 498 minus 504 over 2008 minus 2000. And for verbal, we get So it decreases by a point. So verbal decreases by 1 point per year. And we'll put math over here. We can see math is increasing by 1 every 8 years. So 1/8 of a point, it increases each year. Now on some of these, they have a chart and you have to fill out this spot. I already did some of it, so it'll go quicker. But when you're finding the average rate of change between these, you think of these as your 2 points. And the reason that there's no data for the first one is there's no other point to subtract it with, because we need to subtract these and divide by these being subtracted. And so the second one, we can take 55.4 minus 36.8, and you divide it by 1990 to 1985, or just 5. And this one was an increase of 3.54. Then the next one, you use the next two sets of points. And we subtract the 68.5 and the 54.5 and divide by this difference, which is 5. And then the next one, this minus this, divided by, again, 5, gives us a negative. And the last one gives us also a negative, taking 36.9 minus 49.8 and dividing by 5 again. So that's how you would do it in a chart. We can also look at the rate of change as constant, increasing, or decreasing when we're looking at a graph. And if we're looking at a graph that's constant, it doesn't have to be horizontal. It can be a straight line, because this slope is constant. It keeps growing at the same value. To be increasing, that means the slope keeps changing and it's increasing. Like if we went like this, our slope would keep increasing. If we found the slope here and then here and then here, it would be different. So the slope is increasing. Now, decreasing rate of change does not mean that the graph has to be decreased. If we graph the square root graph, goes like this, this rate of change is decreasing. The slope is decreasing as it goes up. Yeah, it's still positive, but it's not growing as fast as it did before. So the amount this is growing by, maybe this is 3 and this is 2 and this is 1, but it's growing by less. You can also tell a graph by looking at the charts. And again, kind of like we did up in this problem, you have to find your slopes or rate of change. But look at this, these are all growing by 1. So when we find this rate, we're dividing by 1. So 5 minus 2 is 3 over 1. And this one, 8 minus 5 is 3 over 1. 11 minus 8 is 3 over 1. This is constant. And the slope is 3. So this would be the straight line. Call this A. So this will be A. Because it stays constant, that would be a straight line. And if we needed the slope would be 3. This would be linear because these are all the same. Now this one, again, this is going by ones. This one's not. This is going by 2, so it'd be 2 over 1. And the next one goes by 2 over 1, but then the next one goes by 4 over 1. So it's increasing. It's starting out about the same, but then it's increasing. It's jumping from 2 to 4. So it would definitely be this one. This one here, it should be decreasing. If we look here, this one goes by 1, but this one goes by 3, and this one goes by 5, just by subtracting. 9 minus 4 is 5, 4 minus 1 is 3, and 1 minus 0 is 1. And do the same thing on this side. 2 minus 0 is 2, 4 minus 2 is 2, and 4 minus 6 is 2. But we're dividing by 1 here. Here we're dividing by 3. And this one we're dividing by 5. So this is definitely decreasing, which would be this one, C. So you want to find each of your slopes. When we're given a graph, we can also find the slope, because remember I told you slope was rise over run. And if we always start at your leftmost point, we have to go up 2 and over 1, 2, 3. So from here we went up 2, that got the top number, and then over 1, 2, 3. So rise over run. Notice that the graph is increasing because it's going up. Always go from left to right. So this would be a positive graph. This one's going down, so it's a negative, and it's decreasing. And to find the slope, again, start with the leftmost point. We go down 2 and over 1. So down 2 and over 1. Since we're going down 2 and then over a positive 1, our slope's a negative 2. These two are special cases. When you have a horizontal line, the slope is 0. But when you have a vertical line, the slope is undefined. You just need to memorize those. They're two special cases. Given 2 points, we can find the slope using this formula. Notice we're subtracting change in y over the change in x. So if we have x1, y1, and x2, y2. 3 minus a negative 6 over 2 minus a negative 5 equals, this will be a plus, so we have 9 over 7, or 9/7. 9/7 is our slope. That's a positive value, so that means the slope would be increasing. Going like this. Let's try one more. So 4 minus a negative 1 over 2 minus 3. So we have 5 over a negative 1 or a negative 5. That means this slope would be decreasing because it's a negative. Now, this one, they want us to find the missing value. But you're still using your slope. It would be 1 minus y over negative 2 minus 3 equals, and it said the slope was a negative 4. So then we can simplify. We have 1 minus y over a negative 5 equals a negative 4. Multiply the negative 5 to the other side. And that cancels and leaves 1 minus y equal to positive 20. Okay. Looked blurry at first, but subtract the 1 to the other side. You get a negative y equals 19 and divide by negative 1. Y equals a negative 19. So if y is a negative 19, the slope would be a negative 4. Try one more. We have slope 9 minus 6 over x minus 5 equals, in this case, the slope is 2/3. Now, when you have a fraction on both sides, we could cross multiply. But 9 minus 6 is 3, and 3 times 3 is 9. So 9 minus 6 is 3, and then when I cross and multiply that, 3 times that 3 is 9, and 2 times x minus 5. We need to distribute and get rid of our parentheses. So that 9 equals 2x minus 10, the 10. So that 19 equals 2x, and then divide by 2. So x equals 19 halves. Now this one, they want to see if these are coplanar. What coplanar means is they all are on the same line. Or sorry, collinear. Coplanar would be on the same plane, but collinear is on the same line. To be on the same line, the slopes between all of them need to be the same. So if we label these A, B, and C, we'd need to find the slope of AB, BC, and AC. So first finding the slope of AB. These two. 7 minus 3 over 4 minus 2. 7 minus 3 is 4 over 2, which is 2. Now find the slope for AC. 15 minus 3 over 8 minus 2. 12 over 6, which is also 2. So if the last one, BC, is the same, then they are collinear. So BC, 15 minus 7 over 8 minus 4. Since all the slopes are the same, these 3 points are collinear. If any one of them would not have been the same, then they would not all be on the same line. Okay, section 2.5, I think this is. Well, if we look at these two graphs, which one looks steeper? This one does. It looks like it's dropping a lot faster than this one. But if we find the slopes of each of them, because notice the units, this one's counting by 6s, this one counted by 1s. So they can manipulate the way a graph looks like just by making units different. Even though it's a true graph, it can look different. This could look like a big drop. And so if we look at the slope here, notice we're going down 6 and over 1. So the slope of the first one is 6. The other one, we go down 4 and over 1. It should be negative 6, though, because it's decreasing. This one, we're going down 4 and over 1. So it's a negative 4 over 1, or negative 4. This has the bigger drop. So we thought it was this one, but actually because of the units, it's this one. It's dropping by 6 units, but this one only drops by 4. Okay, for the next two, they're a story problem. So I was just going to read them, but I did write the start of the problem. Number 6, it says, suppose the equation E of n equals 5,000 plus 1,000 n and G of n equals 12,000 plus 800 n gives the total cost of operating an electrical E versus a gas G heating and cooling system in a home for n years. So this is our electric cost, this is our gas, and this n is years. Find the cost of heating a home using electricity for 10 years. So electricity, n is years, which is 10. And we just plug that in. 5,000 plus 1,000 times 10 is 15,000. It's $15,000 to use electric. Find the cost of heating a home using gas for 10 years. So 12,000 plus 800 This will make 8,000 plus 12,000, 20,000. So it definitely costs more for gas. Find the initial or installation costs for each system. Okay, when you're looking at an equation like for electric, the initial cost is the constant. This is how much it costs for each year. This was what the beginning fee. Before I used it at all, if you put 0 in here, it's $5,000. So electric cost $5,000 to put it in, to start it up. Where gas, plugging in 0 here to start, our constant is 12,000. So again, this was more. Determine how many years it will take before $40,000 has been spent in heating and cooling a home that uses electric and then gas. So you'll see how long it takes before we spend $40,000. Well, spending or the cost is the function, so it has to go in here. So we're plugging 40,000 equals 5,000 plus 1,000 n. And we need to solve it. So the first thing we do is subtract the 5,000. And we get 35,000 equals 1,000 n. And you're still trying to get n by itself, so you divide by 1,000. So using electric would take 35 years. Using gas, if we put the 40,000 in, we'd first subtract the 12,000 and get 28,000 equals 800 n. So then we take the 28,000 and divide by 800, and we get 35. So once we're using it for a while, the gas and the electric do catch up to each other. But to start with, the electric is cheaper. Number 9. A residential customer in the Midwest purchases gas from a utility company that charges according to the formula C of G equals 11 plus 10.5 times G, where C of G is the cost in dollars and G is 1,000 cubic of gas. And as you can see, I labeled it. Always label your variables so you know what they stand for. And then when you're going to give an answer or plugging in, you know where to plug it in. Another thing is units. Cost is dollars, and G is 1,000 cubic feet of gas. Okay, so let's look at part A. It says to find C of 0, C of 0, 5, and 10. All you're doing is putting in 0 for G. Which gives us 11. So our cost in dollars, it's $11, and that's when we've used no gas. The next one, we're using 5,000 cubic feet of gas, and it will tell us the cost for that. And if we calculate that, you get 63.5. So $63.50 for 5,000 cubic feet of gas. The next one would be 10,000 cubic feet of gas. And we get $116. What is the cost if the consumer uses no gas? Well, the cost if they use no gas, that's when gas is 0, which would be $11. So the cost if they use no gas would be $11. What is the rate of change per 1,000 cubic feet charged for using gas? Okay, your rate of change is in front of your variable, that's your slope, and it's 10.5. So for each 1,000 cubic feet of gas, the cost goes up by $10.50. How much would it cost if the customer uses 96,000 cubic feet of gas? Okay, so 96,000 cubic feet. Well, 96,000 cubic feet. That's our G value. So we want the cost for 96,000 cubic feet. Now we don't put 1,000 in because that's our units. We take that 1,000 out. We only plug in 96. And it's $1,019. Pretty expensive. Okay. A few more working with rates of change. A hiker can walk 2 miles in 45 minutes. What is the average speed in miles per hour? So they can go 2 miles in 45 minutes. Now we want to change it to miles per hour. And so we know that there's 60 minutes in 1 hour. I put minutes on the top because I wanted minutes to cancel, and I also wanted hours in the bottom because it's per hour. So if we take 2 times 60, we get 120 over, and the minutes canceled, so that's miles in 45 hours. And then we divide those. And we get approximately 2.66666, so 2.7 miles per hour. What formula can be used to find the distance traveled in miles an hour? Okay, so our rate of change is 2.7. Distance traveled here is D. Our distance equals, if we're going 2.7 miles for each hour. So it's always your rate of change times your variable. And then if there was a fixed cost, if they said he's already walked 5 miles and he walks at 2.7, then you'd have that 5 on there. But you're starting with no distance. A new $25,000 car depreciates by $5,000 per year. Notice $5,000 per year, that's your rate of change. Construct a linear equation for the value V after time t. Remember, M is our rate of change and B is our slope, our y-intercept. This is the slope. But they want us to use V. So V equals the rate of change. It depreciates by 5,000 per year. So depreciate 5,000 per year, and year is our time. And the starting value is 25,000. That'll be our formula. So rate of change always gets to go with the variable. A starting amount, in this case 25,000, would be your B. One more. In the equation for the line with a vertical intercept at -1 and a slope of 6. Vertical intercept is the same as x-intercept or y-intercept. Vertical intercept. I guess that would be your y-intercept. Vertical intercept is a point where the graph, the function, intersects the y-axis. Okay. So it is your y-intercept. It's not used very often, but it would hit the y-axis at a -1. And then since our slope is 1, we could go up 6. 1, I didn't leave enough space. One, 2, 3, 4, 5, 6, and over 1. So then this would be your graph. But they want the equation, and it said the slope was 6, and the y-intercept, or the vertical intercept, is a -1. That's it for section 2.1 through 2.5.